So, this is called as the correlated occurrences analog to lexical semantics. So, that is the name given by the authors. It is the acronym is COLS. Let us see what these authors have done. So, again this paper is available, you should read. Again, this is a very simple paper to read. This one, an improved model of semantic similarity based on lexical co-occurrence by Rode and others. Okay. So, this was published in 2006 CSM. They are not very far away. Okay. So, for the first one I think it was around 1996, this paper is in 2006, and the third one that we will talk about is in 2014. Again, this is not a supervised model. The third one also is not a supervised model. Okay. Okay. So, in this case again it is very similar to HAL. We are going to be capturing the co-occurrence counts, typically ignoring closed class neighbors. Let us find out what they are little later, using a ramped window whose size is 4. So, it is very similar to HAL, but in this case we are not using a ramped window of size 10, but we are using a ramped window of 4. Discard all but the M columns reflecting the most common open class word. The high frequency words are taken off. We are taking only the most common ones. Convert the counts to word pair correlations. So, this is one change that we are making here. We are introducing the correlations here instead of just the counts. So, instead of using the raw frequency score, correlation score is used to analyze the relationship between the pair of words. Okay. The mechanism of building the term matrix is the same. Only thing is the window size is 4 and we still have the ramped window. And then in this case we are using a correlation where the values would be in the range of -1 to +1. Okay. So, that is what the fourth bullet point is saying. Set the negative values to 0 and take the square roots of the positive one. This is somewhat odd. There could be different ways of doing this, because the values of the correlations are very small. They want to scale it up and they use a square root option. The semantic similarity between two words is given by the correlation of their vectors. Okay, the correlation coefficient values with this normalization will be in the range of -1 to +1. The matrix constructed using this correlation would be called as the semantic space. Right. Since we are creating the word vectors which are actually bringing out the similar words in the same vector space, we call it as the semantic space. In HAL, high frequency neighbors have undue influence on the scores. In COL, we use a normalization strategy that largely factors out lexical frequency. Columns representing low frequency words are also removed. So, they are considered as noise. So, they are removed. High frequency ones are removed, low frequency ones are also removed. Okay. So, let us see how this could be done. Again, I do not want to get into the details of this. If you want to build this, you start in this fashion, right. For how, you are going to have 4, 3, I am sorry, 2 and 1, and then you keep moving that ramped window over the entire corpus and then start computing the count of the co-occurrences. So, the first step is to create the co-occurrence matrix. It is very similar to HAL. There is no difference, except that we do not do from right to left. There is only one in one direction we are doing. In HAL it is direction sensitive, whereas in this case it is one direction. So, if you look at this particular matrix built using this, you will see a symmetry. Okay. And then in the second step what we do is we convert that into correlations. I am sure you know how to compute the correlation between two random variables. So, in the same fashion we can compute the correlation between two words, and then the values are negative and positives. If the values are all negative, what we are going to be doing is we are going to be taking off those negative values, and then the authors are advising that we should square the small values that you find here. For example, in the case of Chuck, okay, the value is 0.014 and they square it to get the, rather square rooted, the values are positive values are square rooted get this value. Okay. So, this is the step 3 part of it, and then once the step 3 is completed, you have your word vectors. You can either take this one or this one, the row one, right. They are going to be the same. Okay. So, what they have done is, again I am not going to go into the details of what happens when you do the correlation and so on. So, I am only going to take the result set and then show how this one is performing, and then is it better than HAL and so on. Okay. So, in this case again they have taken a set of nouns using a 14K model. Okay, so, they have taken just about 14K columns and then trying to find out the similarity for a set of nouns here. So, they are going to be, so I do not want to look at this. Let us look at mind. Okay, so, if you look at the mind, the similar word that Coles found was minds, consciousness, thoughts, senses, subconscious, thinking, perception, emotions, brain and psyche. I think it has done a good job here. Okay, let us look at the cardboard, plastic, foam, plywood, paper, corrugated, boxes, wooden, glass, fabric, aluminum. You remember we saw the cardboard example of HAL. We had some variation there, whereas here you can find that the materials which are very close or similar to cardboard are listed in this. So, by just looking at this list itself, we can say Coles is producing a better result than HAL. The reason could be due to the removal of the high frequency and the low frequency noises that you have in the matrix. Okay. So, let us look at the verbs part of that. So, they have taken 10 nearest neighbors for the verbs that are listed here. Let us take one. I am going to look at the understand here. So, if you look at this, you have comprehend, explain, understood, realize, grasp, know, believe, recognize, misunderstand, understands and so on. I think this has done a good job here too. And then let us look at the adjectives part. What should I pick up? Let us look at the frightened part. Okay. So, scared, terrified, confused, frustrated, worried, or let us look at something else. It's because it found this very well. I am just looking for something which is not really a good one. I am not able to find that. I think all adjectives have really good neighbors around here. All right. So, with the set of nouns, with the set of verbs and adjectives, Coles seem to perform better than Hal, right. So, in this case the word vectors are either rows or columns, either one of them. Okay. One thing that they found was the majority of the correlations are negative. That means, there are a lot of words which are not correlated at all in this space. There are very small set of values that are available which are positive, and those positive values represent the correlations for us. Words with negative correlation do not contribute well to finding similarity than the ones with positive correlation. The closed class words of 147 convey syntactic information than semantic. So, could be removed from the table. The ones are the punctuation marks, she, he, where, after, the, and so on. So, they found close to 147 of them and they removed it. So, they are really not really contributing anything to the word vectors. So, in this case they have used the Usenet corpus of size 1.2 billion words. Okay. So, again by looking at the process of computing the matrix, it is little complex than what we saw with Hal, but the outcome is really encouraging with respect to finding the similar words, right. Okay. So, what are the major differences that you find at this point in time with respect to the supervised versus unsupervised one? So far we have seen these three models. LSI is truly global because it uses the context of document as well, whereas Coles and Hal, they use the local context of 10 words. The only advantage of these two are they actually utilize the count of the co-occurrences. Okay. Supervised model scales well with corpus size. I think even Coles and Hal will also do the same thing. The skipgram model does not use the count of co-occurrence. That is one major difference. So, is it possible to incorporate the count of co-occurrence in the skipgram model? So, can we input that as one parameter inside the skipgram model? So, you remember that, right, especially in the skipgram model we have the word vectors are fed and then we are estimating the context words, right. So, here we are inputting the one hot vector of that word. So, is there a way that I can input the count of co-occurrence into that? Think about it. So, either in this model or in the CBOW model, where we feed the context and only identify the central word. So, can we input the count of co-occurrence in this? So, what will happen if you do that? So, neural nets are supposed to take multiple features as well, right, as part of the input. Think about this. Okay. So, the experiment is all about combining various inputs and trying them out, unless otherwise something is fundamentally wrong in terms of combining two sets of inputs. Okay. So, I am not sure whether there is anyone who had tried that kind of approach in the literature. Okay. Okay, let us get into this part. So, the good model for similarity estimation, because we are using a supervised model. Then frequent phrase identification also is part of that. I did not really cover that part, but skipgrams really would be useful in terms of looking at the frequent phrases. For example, the phrases which are not linguistic phrases, or it is like the New York Times type of phrases, or the Indian Express, the Hindustan Times, and so on. So, those are the phrases which skipgrams also are good at identifying. They are also good at this analogy part. I am not really convinced with the analogy part, because you train the network with a set of analogy and then expect the machine to output that. It obviously will do a good job there. Okay. So, we need to find out whether it can be done in an unsupervised fashion. So, that is where the challenge is. So, with respect to the Coles, HAL or LSI, these are all unsupervised models. They use the co-occurrence statistics. Frequently occurring words have undue advantage in the HAL. We try to reduce that using the Coles model by utilizing only 14K values. It captures only word similarity. So far we are not able to prove that it also captures the analogy part of that.